The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of this sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature, but this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs. And if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored.
When people think of disasters, they imagine something loud. Unexpected earthquakes that snap roads in seconds, gas explosions that bring down buildings, volcanic eruptions that cover entire cities in ash. But sometimes, the real danger is creeping in without a sound. Parts of Arizona are sinking, slowly losing elevation year after year. Why is this happening? And just how much damage can something like this actually cause? Arizona isn't sitting on solid rock. It's sitting on a geological layer cake of sand, clay, and gravel. Think of the ground beneath your feet like a giant wet kitchen sponge. When a sponge is full of water, it's fluffy and holds its shape. That water isn't just in the dirt, it's what's holding everything up. Here's where things go wrong. People pump out that water to use it, but if they take it out faster than nature can put it back in, the gaps start to close. The grains get squished together by the weight of everything above, and when that happens, the ground starts losing the fight. Without the water to hold them apart, the dirt layers collapse under the weight of the world, almost literally. But once that happens, it's not like a sponge anymore. It's like a crushed soda can. You can't just blow air into a flat soda can and fix it. The structure is ruined. Once those underground layers are crushed, they stay crushed forever. Even if it rains for 40 days and 40 nights, the ground can't hold the water anymore. This is called land subsidence. It doesn't matter if water is pumped out or if rainwater rushes away too fast. If underwater pressure drops for long enough, the land starts to sink. And it's not just a one-time thing. Every year that more water is pumped out, the land sinks a little more. Over time, these changes can reshape entire towns and regions. So how do scientists notice something this subtle? From the ground, subsidence is hard to spot. The surface doesn't suddenly drop in one obvious place. Buildings don't suddenly tip over. You won't wake up one day to see your neighbor's house being a few inches lower than yours. Most of the time, everything looks normal. So to really see what's happening, scientists have to look from above. way up from space. Scientists use INSAR satellites, super precise scanners in orbit that can spot ground changes thinner than a US nickel from hundreds of miles away. Using this method, scientists tracked parts of Arizona over several years. What they found was alarming. Large areas weren't just sinking a little. Some places were dropping by inches every year. In certain regions, the total drop added up to several feet in just a short span of time. And this wasn't limited to one small spot. Entire basins were moving downward together, like a slow-motion elevator heading down. What made this even more concerning is that the sinking didn't stop during the wetter years. Even when rainfall increased and water levels rose a bit, the land kept sinking. In some places, this process actually sped up. That told scientists something important. The ground wasn't just reacting to short-term weather, it was responding to years of pressure building underground. Even from space, the pattern was impossible to miss. Wide regions glowing on satellite maps, showing steady downward motion year after year. What looked stable from the street turned out to be quietly shifting across miles of land. And once scientists could see it clearly, a bigger question emerged. What now? The surface can only take so much before it snaps. The land doesn't sink evenly. One spot drops fast, another barely moves. That pulls the surface in opposite directions. The surface tries to stretch, but eventually it snaps. And we aren't talking about sidewalk cracks. The earth literally rips open, creating jagged wounds called fissures, wide enough to split roads apart and damage paved highways. Infrastructure absolutely hates this. Roads bend, twist, and buckle. Pipes and cables buried underground are yanked out of alignment or torn apart. Canals that depend on a gentle, steady slope suddenly stop flowing the way they're supposed to. Even buildings that look fine at first start to give themselves away. Floors can tilt, doors might refuse to close, and long fractures can appear across walls. Wells are affected too. As the ground compacts, it crushes the underground rock layers like a vise. This closes off the flow, turning a working well into a dry hole. Basically, by pumping too much, we're breaking the pump. But it might get worse. These problems spread across entire basins, meaning damage can show up far from where the sinking first began. By the time surface damage becomes obvious, the underground changes that caused it may already be locked in, which means the real challenge isn't fixing the cracks you can see. It's dealing with the ground that's still slowly changing beneath them. So, can this be stopped? Or maybe reversed? Here's the harsh reality. There is no undo button for this. Once that underground rock is crushed, it stays crushed. The best we can do is step on the brakes and stop it from getting worse. One approach is artificial recharge. Arizona has built massive systems to move water across the state. One of the biggest is the Central Arizona Project, a canal that stretches more than 330 miles, carrying water from the Colorado River deep into the desert. They dump massive amounts of water into giant empty fields called recharge basins, letting it seep back underground to repressurize the earth. It's not fixing the crushed sponge. That damage is done. It's more like loosening your grip so you don't crush it even more. You don't get the space back, but you can keep things from getting worse. The other approach is tougher. Arizona drew some hard lines on the map. They're called active management areas, and inside them, groundwater use is tightly limited. You can't just drill a well anywhere and pump non-stop anymore. The goal is to stop one area from sinking so fast that it pulls everything around it down too. In places like Phoenix and Tucson, where these rules kicked in early, the sinking actually slowed down. In other parts of the state, where pumping stayed heavy and rules were looser, the ground kept dropping. Not because the idea doesn't work, but because slowing subsidence only works if pressure is eased early. Arizona is just the latest member of the Sinking Cities Club. In fact, there are far worse cases around the planet. Look at California. The Central Valley there is basically the world champion of deflation. Farmers have been pumping water out of the ground so aggressively for so long that in some spots, the land has dropped by 30 feet. It's gotten so bad that gravity-fed canals are confused because water doesn't like flowing uphill. Then you have Mexico City. The problem there goes back hundreds of years. The city was built right on top of an ancient drained lake bed. As water was pumped out to support a growing population, the ground began to sink. In some neighborhoods, buildings now sit many feet lower than they did a century ago. Streets have been repaved again and again, not because they wore out, but because the city itself kept dropping. It's happening all over the map. From coastal towns to big farming hubs, the ground is getting tired of holding us up. Arizona is just proving how sneaky this can be. It quietly reshapes the world while we're busy looking at our phones, which makes you wonder. If huge chunks of the planet can sink this quietly, how many places are changing right now without anyone noticing? It really makes you rethink the phrase solid ground. Maybe the ground floor will become a basement in 30 years. Or maybe it's just Earth sending us a bill for all the water we carelessly throw away. Okay, just like Arizona, those jokes are a bit dry, so I'll stop now before I sink any lower. Thanks for watching, and try not to let the situation get you down. Have you heard of Thacker Pass in Nevada? Probably not, but you should. There's something so valuable here that the US government invested around $2.26 billion to get it. No, it's not oil. That's a bit old-fashioned, huh? It's lithium, the lifeblood of electric vehicles, smartphones, and renewable energy storage. White gold, so to speak. And successfully mining it out from Thacker Pass could maybe reshuffle the global balance of power. But first of all, why here? Why Thacker Pass? Well, it sits on the edge of something called the McDermott Caldera. Millions of years ago, a supervolcano blew. The ground collapsed into a giant crater. Over time, water collected inside it, forming a shallow lake. Volcanic ash and rock from the surrounding cliffs slowly eroded into the lake bed, carrying with them all kinds of minerals, including lithium. As the lake dried up, those minerals stayed behind, building up thick layers of lithium-rich clay. And for decades, it just sat there, untouched. But now, with interest in electric vehicles being at an all-time high, this area in Nevada has suddenly become one of the most important pieces on the energy chessboard. Lithium ions are tiny, fast, really good at carrying electric charge inside a battery. Think of it like a game of ping pong happening in there. When you charge your phone or laptop, lithium ions zip from one side of the battery to the other. When you use your device, they bounce back the other way, creating the power that keeps your screen glowing. But the best part is that this process can go on for a very long time. Sometimes 15 years or even longer. That's why lithium is perfect for things we charge over and over, like smartphones, laptops, electric cars, and even huge power grids. Other metals? They're often heavier, slower, or wear out faster. Lithium's lightweight, fast-moving nature and incredible efficiency make it the go-to choice for our modern, always-on world. Right now, the world can't get enough lithium. Thanks to the electric vehicle boom and the global push for clean energy, demand is skyrocketing. In just the last year, global lithium use jumped by nearly 25%, and the curve is only going up. By 2030, demand could quadruple, and it's only going up from there. Electric vehicles are driving most of this. Around 85% of all lithium produced ends up in batteries, mostly for EVs. And with gas cars on the way out, every automaker is scrambling to lock in their lithium supply. But it's not just cars. We also need lithium for smartphones, laptops, smartwatches, tablets, power tools, drones, and backup power storage for homes and cities. No more stretching long cables over your yard as you mow your lawn. And let's not forget battery farms being built next to solar and wind farms. All of them rely on lithium to store excess energy when the sun isn't shining or the wind isn't blowing. So the problem is, we're going to need a lot more lithium than we're currently producing. But that's not the only issue. Even if a country has lithium in the ground, that doesn't mean it controls the battery supply chain. Mining is just the first step. Then, lithium has to be processed into battery-grade material. And right now, China dominates that stage, refining around 70% of the world's supply. When the US, Chile, or Australia digs it up, it often ends up in Chinese facilities before reaching a battery factory. That's a strategic weak spot. If global trade gets disrupted because of geopolitics, shipping, or any other reason, the whole clean energy transition slows down. It's kind of like growing our own coffee beans but needing someone else to roast and brew them. You're still dependent, just at a different point in the process. That's why the US isn't just after more lithium. It wants the entire process, from mining to battery production, to happen right here at home. And Thacker Pass could be a big piece of that puzzle. With a $2.6 billion loan from the federal government, this isn't just a mining site. It's a test run for bringing important energy operations back to the US. If it goes well, America won't just be catching up. It might be in the game at full speed. So, what makes Thacker Pass different from other lithium sources? One word: clay. Most lithium comes from hard rock mines in Australia or salty brine fields in South America. Those methods are well established. But here, lithium is locked in claystone, a mix of ancient volcanic ash compressed over millions of years. That kind of deposit is rare and much harder to process. Getting lithium out of clay usually means cooking it at super high temperatures or soaking it in acid baths, which is not exactly cheap or eco-friendly. But if Lithium Americas pulled it off, it could unlock a whole new type of lithium mining, not just here, but across the western US. Early estimates say Thacker Pass could hold up enough lithium to power millions of EVs for decades, possibly the largest deposit in North America. That's why this project matters. It's not just about getting lithium, it's about proving that clay-based extraction can work. If it does, it opens up a new domestic supply. If it doesn't work, the US stays stuck in the same loop. Dig up some lithium, but still send it overseas to get refined and stay dependent. On the other hand, if Thacker Pass reaches full production, it won't just change where America gets lithium, it might reshape the entire region. The mine is expected to run for 40 years and could become one of Nevada's largest industrial projects. That means jobs, lots of them. Predictions say close to 2,000 people could be employed, not to mention the ripple effect: housing, schools, roads, hospitals, and support services. Economists call this the multiplier effect. One mine means more local jobs, waiters, teachers, grocery clerks. The whole town gets a boost. In a rural area like Humboldt County, that's a big deal. And it doesn't stop there. Having a domestic supply means prices stay more stable, sourcing is more secure, and we can increase EV and battery production all over the country. What used to be just a hole in the ground is turning into a national treasure for energy, jobs, and independence. Still think this is just me overhyping it? Let's talk money. The US Department of Energy just ruled out one of its biggest clean energy loans ever, $2.26 billion to get Thacker Pass going. General Motors is investing $650 million to get early access to the lithium they need for their EVs, making this their biggest raw materials investment ever. Tesla has already set up a lithium refinery in Texas so they can cut out the middleman. Even ExxonMobil is getting in on the action, planning to start lithium production by 2027 and aiming to be a major US supplier by 2030. When oil giants, car manufacturers, and the government are all putting their money on the same bet, that's definitely more than just a trend. That's a real change. So what happens if this lithium boom hits a wall? It's possible. Lithium is a limited resource, but the future doesn't rely on fresh mining. Battery recycling is getting better fast. Some analyses even project that future recycling could recover up to 90% of lithium, and new tech is making it cheaper and cleaner to do so. In theory, someday your dead phone battery might power someone's new car, and there's new battery tech on the horizon. Solid-state sodium-ion and thermal batteries are all in development. They're not ready to take over just yet, but they're coming. So no, we're not facing a lithium apocalypse, but we are in a race to mine smarter, recycle better, and stay ahead of future shortages. For now, lithium still runs the show. Somewhere out there in the Nevada desert, there's a dusty construction site that might just shape the future. Not just of batteries, but of global energy, manufacturing, and independence. Thacker Pass isn't just about digging for metal. It's about shaking up the supply chain, giving the economy a boost, and stepping into the clean tech game. If everything goes smoothly, this chunk of land could power millions of cars and help energize the country too. We just have to wait and see.
Okay, Smarty Pants, answer this one. Do you know what earthquake magnitudes actually feel like? Well, at magnitude 1, you wouldn't notice a thing. At 3, you might slosh your coffee if you're drinking. At 5, things can start to shake off shelves, and it definitely gets your heart racing. But at 7.5, that's when the ground itself rips, buildings sway, and whole streets can split. And now, scientists warn a fault we thought wasn't active anymore could unleash something that strong under a small sleepy town in Canada. Now, if you trace your finger across a map of northwestern Canada, you'll find Dawson City in the Yukon. It looks like a nice place to escape from civilization. After all, it only has about 1,600 residents. It's quiet, remote, and famous for its gold rush past. In the late 1890s, Dawson City ballooned into a boomtown almost overnight as prospectors chased gold. Today, the rush is long gone, but the town still looks the part. Wooden boardwalks and saloon-style facades give it the feel of a set straight out of a Western movie. Oh, and beneath all of that is a fracture in the earth itself. Dawson City is located on top of what's known as the Tintina Fault. It's a massive crack in the Earth's crust that stretches for hundreds of miles toward Alaska. Until recently, scientists believed that this zone had been inactive for over 40 million years. But newer studies tell a different story. Just a quick reminder, faults are giant cracks when two slabs of Earth's crust meet. They're always trying to slide past each other, but their jagged edges catch and lock. Pressure builds for decades, continuously bending and straining the rock. Then, suddenly, the locked zone breaks, and the slabs slip into a new position in just seconds. That abrupt lurch releases all the stored energy, sending seismic waves racing outward. The ground-shaking consequence is called an earthquake. Scientists say the ground on each side of Tintina has been trying to slide past itself for ages, but it's stuck. And now, that stuck zone has built up around 20 feet of strain. That's how far the land would shift sideways if it all gave at once. That's not just a small crack. That's straight up something from a disaster movie. If all that built-up tension snaps in one go, the result could be a magnitude 7.5 earthquake. How strong is that? Well, pretty strong. So, what happens during a big quake? The shaking can last up to 30 seconds or more, which is an eternity when the walls are swaying and the floor feels like it's rolling under your feet. If you're near the fault, things can get really scary. The ground doesn't just shake, it could take a big step sideways. This can lead to some renovations. Roads might get a new zigzag pattern, and unreinforced buildings could decide to do the twist. And if it happens in a Canadian winter, let's just say it could turn a simple power outage into a survival horror adventure. Being on soft soil is like sitting on wobbly jelly. It amplifies the shaking. Solid rock is a bit more stable. However, it's still dangerous. For example, in Mexico in 2003, a 7.5 quake damaged over 43,000 homes, buckled roads, and cut power for miles. In Sulawesi in 2018, the same magnitude not only leveled buildings, but triggered a tsunami and liquefaction. The whole neighborhood was swallowed as the ground turned to quicksand. Now here's something interesting. Most people don't think of Canada as an earthquake country, but it actually gets around 5,000 quakes a year. However, they're so small that you'd never feel them. The real hot spot is the West Coast, near British Columbia. That's where you hear people whisper about the infamous Big One. It refers to a future megathrust earthquake along the Cascadia subduction zone, a massive fault that runs for 600 miles just offshore. Unlike Tintina's sideways slip, Cascadia works by one tectonic plate shoving under another. For centuries, the North American plate has been bent upward like a spring as the Juan de Fuca plate has been diving below. When it finally snaps, that's a magnitude 9.0, more than 30 times stronger than a 7.5. We know it can happen because it already has. The last big one struck in 1700. It was so powerful, it didn't just shake the Pacific Northwest. It launched a tsunami across the ocean that smacked Japan, where villagers recorded an orphan wave with no local quake to explain it. Only later did scientists connect the dots. Now this brings us to the fact that despite all this, the size of the fault, the quiet buildup of strain, and the potential for a magnitude 7.5 earthquake, the Tappan fault isn't even listed on Canada's official seismic hazard map, at least for now. That means no warnings, no color-coded danger zones. And when a fault isn't on the map, nobody designs a building for it. There's no proper preparation. You don't build reinforced structures or have seismic codes, especially when people don't expect that the ground could split open. Now, to be honest, that's not someone's mistake. The fault just didn't show any signs of being active recently. And this part of Canada is really big, quiet, and doesn't have a lot of monitoring. Not until too long ago, people had thought of the Tappan as just a geological oddity, something cool for looking at the past, but not really relevant for the future. For years, the Tappan fault flew under the radar, but that changed when researchers brought high-tech gear. They uncovered subtle but clear land shifts near Dawson City. They looked like scars on the landscape and pointed to past earthquakes, including one that pushed the land nearly 3,000 feet over millions of years. Now, interestingly, newer glacial features showed no signs of disruption, which means the last major quake probably happened right before the end of the last ice age. In geologic terms, that's pretty recent. When scientists lined up those land shifts with the ages of glaciers, the picture was clear. The Tappan fault isn't retired, it's just been on a really long coffee break, and now it's itching to clock back in. That's why researchers want it officially on Canada's seismic hazard map. Dawson City deserves more than a shrug emoji when the ground decides to stretch. The experts are basically playing detective with dirt. They're scanning forests and rivers for faint scars that past earthquakes tried to hide. They're digging trenches like archaeologists with a taste for chaos, flipping through the Earth's diary one muddy page at a time. Every crack, wrinkle, and layer adds to the story of when Tappan last threw a tantrum and how loud the next one could be. It's pretty cool that satellites can literally track if one side of a valley is slowly creeping ahead of the other, like tectonic snail racing. The goal is to find out how often this fault snapped in the past, how much stress it's still holding on to today, and whether it's going to go off quietly or all at once. Finally, just because you know that plates are pushing against each other underneath, you still can't put a date on it. Long stretches of silence might mean the rocks are getting ready for something huge, or they could just be releasing stress in tiny ways that go unnoticed. Scientists can model possibilities, but no one has a countdown clock for the next rupture. The smartest mindset isn't prediction, it's preparation. You brace for the plausible, not the precise, because the Earth's schedule doesn't come with reminders. It turns out the Earth's crust is always fidgeting. It's just that our maps are a little behind on the gossip. A fault everyone thought was harmless might actually be sitting on a magnitude 7.5 size secret. But don't worry, this isn't a cue to panic. It's a cue to get smart. Better data, sturdier buildings, and a few just-in-case habits. When the ground finally decides to settle its debt, what really matters isn't whether Dawson City feels the shake. It's whether everyone's prepared enough to turn a potential disaster into just a real wild story to tell later. Hey, have you ever been in an earthquake? I have. Tell me your story in the comments. In the winter of 2019, the American Midwest and Northeast turned into a real-life disaster movie. I'm talking about that time when temperatures dropped to negative 63 degrees Fahrenheit. There were massive flight cancellations and power outages, dozens of injured people, and shut down schools and offices. Simply going outside became highly risky. And if you're looking for someone to blame for all this, I've got 2 words for you: polar vortex. That's not some scary storm, but a huge mass of cold air that's normally spinning counterclockwise around the poles. When it's summer up in the northern hemisphere, the vortex stays further north, and in the winter, it heads south a bit. The term polar vortex has been around since the late 1940s. It shows up every winter and calls it quits in the spring. But for about the last 20 years, this polar vortex has been acting weird in the middle of winter. It looks like it either splits or becomes displaced once every other year. At the bottom of this vortex is what they call the polar front, or the polar jet stream. This jet stream moves from west to east, which is why places like the northeastern part of North America get hammered by that chilly polar vortex weather.
Ooh.
These jet streams zip along because of differences in temperature and the Earth's spin. When there's a big gap in temperatures, the winds really pick up speed. In spots like the equator, where the sun's rays are more intense, the air heats up and starts to rise. And as it goes up, it leaves behind a sort of empty space, taking in air from all around, kind of like a huge vacuum cleaner. But over at the poles, where it's way chillier, the air shrinks and sinks, forming areas of high pressure. It's like a bunch of air molecules trying to spread out, like a group of school kids on a big field. So you've got these 2 forces at play: warm air rising and cold air sinking. Air wants to zoom from the poles down to the equator with this setup. The jet streams tend to hang out where airplanes fly, about 30,000 feet in the air. Pilots often use them to zoom across the sky faster and save some fuel. But these jet streams aren't always the good guys, as they can bring all sorts of weather changes, like cold snaps and heat waves. When the polar jet stream is strong and cruising at about the same level as the vortex, it kind of locks in that cold Arctic air within the Arctic Circle. Every now and then, the jet stream takes a chill pill and starts moving around the planet in a wavy pattern called Arctic oscillations. This creates peaks and troughs that allow warmer air from down south to head north, and the chilly Arctic air to take a trip south. In the northern hemisphere, there are 2 polar vortexes, one in the lower atmosphere known as the troposphere, and another higher up in the stratosphere. The stratospheric vortex forms as cold, dense air sinks and twirls near the North Pole. The mightier the vortex, the quicker it spins, keeping cold air locked over the high latitudes. When someone or something messes with the polar vortex, it goes haywire. Picture a spinning top. Give the table a shake and it'll start wobbling. When the polar vortex loses strength, it can't corral the cold air anymore. So, blasts of icy Arctic air surge southward over North America. The polar vortex isn't a fixed object, but more like a living being. It gets stirred up by ripples on Earth's surface, triggered by stuff like air flowing over mountains or across land and sea, all warming up differently. If our planet were as smooth as glass, with oceans wrapping all around, the polar vortex would just chill out, never breaking up. But every time a wave smacks into it, it gives the vortex a push. Sometimes, one of these waves packs enough punch to shove the vortex off the pole or even spin it in reverse. And when that happens, the temperature in the polar stratosphere can skyrocket by a whopping 50 degrees in just a week. The Arctic's polar vortex started spinning in the opposite direction in March 2024 and got scientists worried. It's one of the 6 strongest flips since the 70s. This time around, it hasn't caused any chaos. Sometimes the waves of air affecting the vortex get strong enough to split it into 2 parts, kind of like how a cell divides. They're called daughter vortices, and they even add more chaos to the mix. When the vortex splits, one chunk usually heads over Siberia, while the other cruises over North America. Once that split goes down, the jet stream in the troposphere above the Atlantic decides to take a southern vacation. That jet stream usually acts like a bouncer, keeping the chilly Arctic air up near the pole. But when it heads south, that Arctic air gets a green light to crash the party in places like the East Coast, the Midwest, and even Western Europe. The storms that usually ride along with the jet stream follow along and head south too. They take their time to get organized and catch up with the new path of the jet. So, instead of hitting up Canada like they usually do, they swing by New York and Chicago for a change of scenery. Scientists still don't know why the polar vortex doesn't mess with the U.S. Pacific coast. It might have something to do with where the jet streams hang out in each basin. Over in the Atlantic, the jet stream kicks it at higher latitudes, while in the Pacific, it's chilling closer to the equator. It might also have to do with the landscape. In the Atlantic, the air has zipped over the Rocky Mountains, stirring up waves off tall peaks that mess with the jet stream. But in the Pacific, the jet stream is away from any big mountains that could cause trouble. The recent reversal of the polar vortex is unlikely to make the temperatures drop extremely, but scientists aren't sure what's going to happen to the polar jet stream in the future. They're concerned that the chilly polar air might make more trips down to the mid-latitudes and bring along more chilly spells in the long run. So it's better to be prepared. When the news tells you there's a huge winter storm coming and power outages are highly likely, fill your bathtub with water. If you have an electric water pump, it won't work and you'll run out of water soon. Gas stations also run on electricity, so fill your car tank before the storm hits to have some emergency gas. When the storm arrives and you're locked in, put on several layers of warm clothes, thermal wear, a warm shirt, a sweater, and insulated pants and woolen socks. Don't forget mittens so the heat doesn't escape through your hands. Hang dark blankets on your windows to draw in heat. Make sure your doors and windows are closed well, and put some towels under them to prevent drafts. Your basement is probably more insulated by the ground, so it could be a good place to spend the night. To warm up the cold winter bed in your home, fill a bottle with hot water and place it in your core region under the cover. The water will heat up your vital fluids traveling through your body, reaching all the extremities and warming you up in no time. You can also wrap your pajamas around the bottle before putting them on for an extra effect. When the power comes back on, check all your appliances and electronics before turning on the main power switch. They must be unplugged to avoid power surge damage. As you turn the water supply back on, keep the taps on the lowest level of your house closed to let the air out from the upper taps.
Some mistakes have the power to change the course of history. One such story has to do with an old, boring key that could have saved the Titanic from its infamous demise. The key belonged to the crow's nest locker that housed binoculars, which could have helped the lookouts spot the iceberg sooner. There's more. The key wasn't even on board the ship when it set sail. The second officer took it with him when he was taken off the ship at the last minute. As the story goes, the officer forgot to hand the key over to his replacement in his hurry to disembark. So, when the lookouts were in desperate need of binoculars, they were out of luck. One of the lookouts, named Fred Fleet, even testified that if they had had binoculars, they would have spotted the iceberg in time to avoid it. And when asked how much sooner, Fleet replied, "Enough to get out of the way." In 2015, some auctioneers got their hands on Blair's key and presented it as one of the most important artifacts from the Titanic. They truly believed it could have saved the ship. Blair kept the key as a souvenir and passed it down to his daughter, Nancy. At one point, it was up for auction with a price tag of over $80,000. Blair himself was quite the hero, it seems. A year after the Titanic disaster, he was awarded a gallantry medal for saving a crewman who had fallen overboard while he had been on board the liner Majestic. He may have forgotten a key, but he sure didn't forget to be a hero when it counted. This next story is both funny and tragic. It's about NASA's lost $125 million Mars Climate Orbiter. The spacecraft engineers failed to convert from English to metric measurements before the craft was launched, and as a result, they lost it. The navigation team at the Jet Propulsion Laboratory used the metric system of millimeters and meters, while Lockheed Martin Astronautics in Denver used the English system of inches, feet, and pounds. JPL engineers mistook acceleration readings measured in English units of pound-seconds for a metric measure of force called Newton-seconds. What's worse is that none of JPL's quality control procedures caught the error in the 9 months it took the spacecraft to make its 461 million mile flight to Mars. That's a long time to be lost in translation, don't you think? The miscalculations were enough to throw the spacecraft so far off track that it flew too deeply into the Martian atmosphere and was destroyed when it entered its initial orbit around Mars. It's embarrassing to lose a spacecraft to such a simple math error. And it's hard to think of another example of such a large loss due to English versus metric confusion. Ever heard about the mathematical mistake that led to the discovery of the New World? Spoiler alert, it involves a guy named Christopher Columbus and a really big globe. Back in 1492, Columbus set sail from Spain with a mission to find a new trade route to Asia. He was convinced that he was less than 3,000 miles away from Japan, and just a bit more sailing would get him to the Indies with all their tasty spices. The only problem was that Columbus was a bit off in his calculations, like way off. He made a mistake in estimating the size of the globe, which led him to believe that Earth was far smaller than it actually is. Now I know what you're thinking. Wasn't Columbus afraid that he would fall off the edge of the world? Contrary to popular myth, Columbus and his crew knew the Earth was a globe, just like the ancient Greeks did 2 millennia earlier. They weren't worried about falling off the edge, but rather about the size of the ocean they planned on crossing. And to make matters worse, Columbus had no idea that an unknown landmass existed between Spain and Asia. After weeks at sea, Columbus finally reached the Caribbean. He believed that he had landed on the outskirts of Asia, and so named the islands the West Indies. He went on to explore the Caribbean and the northern coast of South America. But here's where things get really interesting. Even though Columbus insisted until his last day that he had reached Asia, another Italian explorer named Amerigo Vespucci mapped the eastern shore of South America down to Brazil and proved conclusively that Columbus had actually discovered a whole new world. A German mapmaker saw Amerigo's maps and labeled the new landmass America after him. And since his maps were super popular at the time, the name stuck. One man named Alexander Fleming stumbled upon one of the most significant medical discoveries of all time by accident. At one point in his career, Fleming observed the demise of many people from uncontrollable infections. Antiseptics were used to fight this, but they often did more harm than good. In 1922, while he had a cold himself, Fleming transferred some of his, nasal discharge to a petri dish and left it on his cluttered desk. When he finally examined it weeks later, he found that an enzyme had some antimicrobial properties. It wasn't until 1928, when Fleming left an uncovered petri dish next to an open window, that he stumbled upon the discovery that would change the world. The dish became contaminated with fungus spores. And when he examined them under the microscope, Fleming discovered that the bacteria near the fungus were dying. He managed to isolate the fungus and found that it was effective against numerous things that caused diseases. And thus, penicillin was discovered. As Fleming himself put it, "I did not discover penicillin. Nature did that. I only discovered it by accident." Talk about a lucky break. In the early 1520s, the east coast of the United States of America was a big mystery waiting to be solved. The Spanish found Florida, and the English and Portuguese found Newfoundland, but the area in between was like a blank spot on the map. France decided to take action and sent an expedition to explore the area. They chose a guy called Giovanni da Verrazzano to lead the trip. For this expedition, he got 4 ships. Unfortunately, 2 of them were shipwrecked. and a third one went home after doing some other business on the Spanish coast. Only the flagship, La Dauphine, crossed the Atlantic with Verrazano and his 50-man crew. Verrazano set sail from Madeira and landed at Cape Fear. From there, he sailed south, but got a little scared of running into the Spanish, so he returned somewhere north of Charleston. He anchored not far from his original landing spot, but unlike other explorers, he preferred to anchor well out at sea. He did send a boat to the shore, and he met the natives. They were described as wearing just some animal skins covering their bodies and garlands of bird feathers. As Verrazano sailed along the coast, he reached the outer banks of North Carolina. He thought that the waters he discovered were those of the Pacific. In reality, what he'd stumbled upon was the Pamlico Sound. He thought that North America was just a long, extremely narrow strip of land. This mistake led mapmakers to show North America as almost completely divided in two. Moving on, Verrazano reached a beautiful place that he called Arcadia. Probably Kitty Hawk, North Carolina. Sailing further north, he missed the entrances to Chesapeake and Delaware Bays because he kept quite far from the coast until New Jersey. Then, the moment we've all been waiting for, Verrazano discovered New York Harbor, and he anchored in the Narrows. Later, it was named after him, and now it is spanned by the Verrazano Narrows Bridge. Once Verrazano's sea appeared on the map, it became widely accepted and impacted loads of future explorers. For example, Henry Hudson went looking for a passage to the Pacific in the middle latitudes of the continent. But, as it turns out, the Englishman never did find the Pacific Ocean anywhere near Virginia. And the cartographic myth eventually faded away. It's funny to think about how a mistaken belief could have such an impact on history.
There's a place on Earth that looks like it came straight out of the movie Dune. Massive platforms of stone and mud rise in the middle of a scorching desert. And somehow, people manage to survive in such a hostile environment.
Oh, really?
But, unlike the movie, this real city in Peru was abandoned over 3,000 years ago and has stayed hidden from us until now. Meet Pañeco. This lost city is located in the Huaura province, north of Lima. After 8 years of excavation and conservation work, some of its secrets have finally been brought to light. It may look eerie and lifeless now, but it wasn't always this way. Experts think this place used to be a busy trading center for ancient Peruvians. In fact, it was part of the oldest known civilization in the Americas, at least as far as we know. And no, they weren't the Mayas or the Aztecs. That's a common mistake. I'm talking about the Corral Supe civilization. This society existed more than 5,000 years ago. That's super old. To put that in perspective, while the Sumerians in Mesopotamia were reaching their peak, and the Egyptians were just starting to build things in Giza, the people in Corral were already building pyramids. Thanks to them, Peru is now seen as one of the 6 places where civilization first began. But unlike the objects we find from ancient Egypt or Mesopotamia, you won't see Corral artifacts in museums, at least not fancy vases covered in mysterious letters, since they didn't know pottery or writing. What they did know was how to build big. They left behind mind-blowing architecture, such as stepped pyramids and huge sunken plazas, like massive open-air arenas big enough to hold hundreds of people. And it's not like they just had one pyramid here and a plaza there. No, as I said, they built big. So far, researchers have found as many as 30 major metropolitan centers across what we now call the Corral region or Peru's north-central coast. You can think of them as full-on cities, with residential areas, several plazas, and ceremonial temples. Their largest pyramid, known as Pirámide Mayor, stands nearly 100 feet tall, with a base covering an area the size of about 4 football fields. That's substantial.
Oh my God!
And building all that surely wasn't easy. It took planning, coordination, and specialists. That suggests that Corral must have had organized labor and strong leadership to pull it off. Despite creating these incredible constructions, Corral cities stayed hidden for thousands of years. And even when researchers first came across the area, it took decades for them to realize how important it really was. They already knew about the ruins back in the 1940s, but it wasn't until the 90s that the first major study of Corral was done. And there's a reason they were ignored for so long. The architecture was so advanced and the proportions so huge that people thought, nah, this has to be something modern. They couldn't have been more wrong, though. And in 2001, studies finally recognized that Corral was the oldest known civilization in the Americas. Archaeologists believe this society existed from around 3,000 to 1,800 years before the Common Era. And for 4,000 years, they flourished in complete isolation. Chances are they never met another civilization at all. This may explain why they are considered such a peaceful society. Researchers haven't found any signs of conflict. No fortifications, no battle gear, no trace of fighting. Instead, they seem more focused on commerce and, well, pleasure. Looks like they love music. In one of the temples, for example, archaeologists found 32 flutes made from bird bones. I wonder what that sounded like. Anyway, the Corral lived along 3 rivers, the Fortaleza, the Patavilca, and the Supe. Just like the newly discovered city of Peñeco, this lost city was built on a natural terrace, about 1,970 feet above sea level. And no, they didn't do that for the view, it was for security. Building higher up protected them from flooding, since the site sits parallel to the Supe River. Just recently, after 8 years of excavation, experts finally uncovered its beauty. Altogether, they found 18 structures, including temples, residential complexes, and a huge circular plaza. There are also ceremonial halls built on top of large step platforms, along with stairways, courtyards, and carefully designed walls. These structures serve both practical and symbolic purposes. I mean, this was their hotspot, the place where people came together for rituals. Inside one of the structures, researchers uncovered remarkable finds, like sculptures molded in raw clay that portray human figures, animals, and ceremonial objects. They also dug up stone tools, such as grinders, crushers, and hammers. And remember I said they like music, right? Well, the team also found patutus there. That's like an old-school trumpet made of giant shells brought from the Pacific Ocean. Now, if you look at the map, one thing stands out. Peñeco is farther inland than other Corral cities we've discovered. And that's important. The city's location was completely strategic. And that's why it earned the nickname City of Social Integration. There's this theory that says Peñeco played a key role in trading hematite, a mineral used since ancient times to make red pigment. Back then, this was fancy stuff. Peñeco likely served as a hub linking the coastal and highland villages of Supe and Waura. Maybe they traded hematite for fish and shellfish from the coastal villagers. But now comes the big question. What happened to the people who lived there? Why was Peñeco completely abandoned after thousands of years? Well, that still remains a mystery. There are different theories about why the Corral Supe civilization disappeared and why their most important cities were left abandoned. One of them is the maritime hypothesis. It suggests that societies first developed along the coast, relying heavily on fishing, and only later moved inland. So, in that view, cities were abandoned as people shifted away from them. But that doesn't fit Peñeco, right? I mean, it's way too far inland to count as a seaside city. So it's hard to say what really happened. If you look at their main city, archaeologists haven't found any solid evidence of one big disaster. No massive earthquake, no huge flood, nothing like that. And the same goes with Peñeco. There's just no sign of a single event that suddenly wiped them out. The likely explanation is a shift in climate. A change in the weather could have caused long droughts that affected local farming. That would have forced people to abandon their cities, like what happened in northern Mesopotamia. Now, can we say that with absolute certainty? Honestly, no. It's much more likely that several distinct factors led to the decline of that society. They might have also faced some internal conflict, issues of leadership or organization, for example. But that's impossible to prove with archaeology alone. Either way, Peñeco is a huge discovery. It gives us new clues to better understand the crisis the Corral civilization faced before its collapse. But for now, many of their secrets are still waiting to be uncovered. And there's still so much for researchers to figure out about how this civilization was born and how it evolved over time. If you want to visit Peñeco, here's some good news. The site has recently been opened to the public. It's about a 4.5-hour drive from Lima, and you can get there either by a private vehicle or through tourist services. Yeah, it's not the easiest journey, but the breathtaking landscapes will make up for it. And if you don't have the time or the money to fly all the way to Peru, don't worry. If you know Spanish, you can explore a virtual museum dedicated to Corral. It features 10 thematic rooms designed to take you on a journey back to the origins of civilization. You'll find photos, videos, infographics. It's a whole immersive experience. Of course, it's not the same as standing on the site itself, but it still offers a fascinating glimpse into the world of the oldest known civilization in the Americas.
One morning, millions of New Yorkers were going to work, just like so many times before, completely unaware they'd just missed an incredible bridge replacement project. A team of engineers and builders replaced the 3-mile crossing with a new structure built to last 100 years. But the real magical part is, it happened so quietly that nobody even noticed. The Tappan Zee was the longest span in New York State from the day it opened in 1955 until 2017. It wasn't close to being the longest bridge in the US, but if you look at it from above, you can understand why people made the comparison. The name Tappan Zee comes from 2 parts. Tappan, the name of the local Lenape group that lived in the area, and Zee, the Dutch word for sea. But the interesting part is why it was built there in the first place. It wasn't chosen for the scenery or the engineering conditions. It was selected because of a minor monetary technicality. Someone realized, if we move the bridge just a bit farther north, New York doesn't have to share a single toll dollar with New Jersey. And just like that, a line on a map decided where millions of commuters would cross the river for the next 60 years. When the bridge was finally built, it was the era of black and white movies, rebuilding, and material shortages. The designers worked with a tight budget and predicted the structure would last about 50 years. Back then, it made sense. Traffic was lighter, cars were smaller, and nobody in the 1950s was imagining 6-lane rush hours packed with SUVs, delivery trucks, and non-stop commuter traffic. But the world didn't freeze in the 50s. Suburbs expanded, highways grew, populations shifted outward. And day after day, year after year, the Tappan Zee quietly took on more than it was ever meant to handle. By its later decades, it was carrying over 140,000 vehicles a day. Replacing it wasn't like building a new playground while kids were still playing. Shutting the span down completely wasn't an option. Traffic would have overflowed onto roads that weren't ready for it. That's why engineers decided to build a new bridge right next to the old one. This is a standard, logical, and most common procedure for major crossings that cannot be closed. However, doing this for a bridge that was longer than many famous bridges in America, as long as the span of Central Park, wasn't exactly a walk in the park. So, how do you pull off the overnight bridge construction? Well, obviously not overnight. In fact, it took years, and it was insanely expensive. But to most drivers, it felt like waking up, looking out the window, and suddenly seeing a skyscraper that they somehow didn't realize was there. While drivers kept using the old bridge, crews built the new one right beside it using equipment normally only seen on massive coastal projects. One of the coolest machines used was the Left Coast Lifter, a floating crane nearly 330 feet tall. That's about the height of a 30-story building. It lifted massive pre-built steel sections, each weighing hundreds of tons, and placed them into position with slow, careful movements. Drivers could see the crane from the road, but because their route hadn't changed much yet, most people treated it like background construction. The new bridge grew piece by piece until the first half was strong enough to carry traffic. For drivers, it felt like the bridge was gently shifting and rearranging itself under their wheels, like a giant concrete puzzle morphing into its new shape one lane at a time. It opened in small steps, planned so drivers wouldn't feel anything unusual under their wheels. Once all cars moved onto the new span, the old Tappan Z was taken apart slowly and safely. Most of it was removed piece by piece using cranes and barges. One section had to be taken down with controlled explosives because it wasn't stable enough for manual removal. But even that was handled early in the morning with everything blocked off and secured. This entire U.S. highway bridge engineering project, the construction, the lane shifts, and the bridge's demolition and rebuild was pulled off, and yet traffic never had to be shut down for too long. But what can we say about the new one? The old Tappan Z Bridge was replaced by the Governor Mario M. Cuomo Bridge, named after a former New York governor. The name might not roll off the tongue, which is why locals still call it Tappan Z, but the bridge itself is an astounding upgrade. It's a true modern structure, built to fix every weakness the original struggled with. For starters, it's much broader. The old Tappan Z never had an emergency lane, which meant even a simple breakdown could freeze traffic for miles. The new bridge finally has space on the sides for cars to pull over safely for emergency vehicles to get through without weaving between lanes. The lanes themselves have been expanded as well to handle the demanding rush hour. It also has backup support systems built into its structure, so if one part fails, the whole bridge stays safe. Another new feature that everyone likes is a shared path for bikes and pedestrians. Now people can walk or cycle across the Hudson River, something impossible on the old span. Even the lighting was modernized. Instead of old orange bulbs, the new bridge uses bright, energy-saving LEDs that can change color for holidays and events. The new system is far more practical and easier to maintain. While the original Tappan Z was built cheaply and quickly, this new one was designed to last at least a century. It has stronger materials, better corrosion protection, and a structure designed for today's traffic loads. But it came with a cost. And it's one question that people like asking when they hear about the upgrade. How much did this actually cost? And where did all the money go? And the answer is bigger than what most people expect. The entire project cost around $4 billion, making it one of the most expensive infrastructure replacement projects in the state's history. To many drivers, that sounds unbelievable, especially since they never felt a major interruption. But the price tag makes sense once you break it down. A large chunk of the budget went straight into the part nobody sees unless they're looking from afar: the foundations. The Hudson River near that spot is wide, deep, and uneven, and full of mud that refuses to cooperate. Engineers had to drill enormous steel piles deep into the riverbed, using machines parked on floating platforms. But then there's the bill for materials used. A modern cable-stayed bridge doesn't use bargain bin steel. It uses high-grade, corrosion-resistant, storm-ready metal and concrete, built to survive decades of trucks, wind, salt, and winter. And these weren't parts you can just pick up at a hardware store. Giant sections were custom-made in factories and shipped in by barge. However, this method was what made the whole overnight bridge construction process possible. The new bridge arrived in pieces and was literally pieced together. Labor and logistics made up a huge part of the cost. Thousands of workers rotated through scorching heat, freezing cold, fog, and rain. Coordinating barges, boats, traffic, safety crews, and big cranes beside a live highway is nothing like building on an empty lot. Every phase had to line up with the next, because one mistake could have shut down the whole crossing. That kind of workforce and planning is a big part of why the price tag was so high. But given that the bridge is breathtakingly long and will last at least a century, it looks like a significant investment. Replacing the old Tappan Z wasn't about breaking records or building the longest bridge in the US. It was about proving that a massive bridge replacement project can proceed smoothly, safely, and almost invisibly. In the modern world, rush hours can feel like a never-ending nightmare, and thousands of outdated remnants will need to be replaced eventually. But if it can be coordinated without actually making someone late for a date or work, then it's truly worth admiring and appreciating.